Hi, my name is Reagan Williams, and I've worked alongside Catherine Shanks and Theo Lease to design a sterilizer to sterilize instruments used in childbirth in low-income areas. This device must also be portable, not depend on electricity, and inexpensive. Due to this criteria, we decided to zone in on one specific country who had the highest number of deaths during childbirth, and this country was South Sudan. Many of those deaths were caused by infection, so that makes this challenge all the more crucial. Some of the current devices that are on the market for sterilization today, and these are the most common that you'll see, are the autoclave and the dry heat oven. The autoclave uses steam and pressure to sterilize its instruments. It works at a very fast pace, and it can be extremely expensive, but that's ideal for hospitals and their fast pace. We also have the dry heat oven, which uses the air around it and pressure and also heat to also sterilize instruments. However, it does not move at the same pace as an autoclave. It takes a little bit longer.
Our team came up with several ideas to tackle this problem. Having taken inspiration from the steam autoclave, one idea is a metal box that is placed above a fire or boiling pot of water until a thermometer shows that the desired temperature has been met, and the medical instruments inside the box are sterilized. While another idea is a dry heat capsule, which uses a vacuum system to pump in outside air, heat it, and spray it onto the tools inside the capsule. This device is powered by batteries and has different buttons for actions like starting and stopping the sterilization process and locking the capsule. Another idea improved upon the existing autoclave design by removing the internal heating and microprocessors, leading to an autoclave that is powered manually and therefore limiting the need for electricity and making it cheaper. The final idea, taking influence from solar ovens, consists of a lightweight box lined with reflective material on the interior sides and a dark-colored antimicrobial material lining the bottom. The combination of these materials directs solar rays into the box, heating it until the medical instruments inside have been sterilized. At the beginning of this project, we determined what criteria our device needs to meet and ranked those criteria using a pairwise chart. By comparing the criteria against each other, we determined that, from most to least important, they order effectively sterilizes, cost-efficient, energy-efficient, portable, user-friendly, and has longevity. Once we had developed our ideas, we compared them to the user criteria using a Pew analysis table to see which one met the most criteria. Each criteria had a weight, which is determined from the pairwise chart, and each idea was compared to the baseline, an automatic autoclave, and then given a ranked score. The box sterilizer met most of the criteria except effectively sterilizes and received a ranked score of 5. The dry heat capsule did better than the baseline in half of the criteria, while the manual autoclave met the baseline for the majority of the criteria but did worse in user-friendliness. Both of these ideas received ranked scores of 6. The solar oven also met or exceeded the baseline for the criteria, with cost-efficient being its biggest strength, and so it received a ranked score of 9. Since the solar oven had the highest ranked score, it was determined to be our team's final idea.
This is a mock-up of our solar oven. It has a Sharklet adhesive antimicrobial panel on the lid. Its walls are made of mirrored Macrolon, and it is held together with acrylic glue and hinges. This is a 3D rendering of our solution, which, as a reminder, is cheaper, does not have an internal heating device, and is portable, making it perfect as a solution in areas that do not have consistent electricity. Thank you.